There are at least more than 100 data structures available today, as you can see from this list I have compiled. Should you memorize them all, or should you learn implementation of every single data structure by heart? Heck no. So what is the right way to learn about data structures? I'm going to explain everything you need to know to fully understand them. But before we dive into that, let's take a step back and try to understand what exactly data structures are and why they're so important. In the simplest term, data structures are ways to organize and storing data so that they can be retrieved and used effectively. Whether it's an array or graph, each data structure has a unique way to manage information. Let's dive deeper and explore 3 key points to understand data structure better and move beyond common misconceptions. There is a common myth that data structures are tied to a programming language, but in reality, data structures are language agnostic. This means the concepts and principles of data structure apply universally regardless of your programming language. Number 2, one size fits all. Many new developers assume there is a one size fits all data structure, but in reality, it doesn't exist. The truth is, each data structure has its own unique strengths and is suited for specific issues and scenarios. And finally, memorization over understanding. It's better to understand data structure rather than memorize them. It's knowing why and how is the key. Now let's back to our original question. How you can learn data structure effectively? With over 100 different data types available, understanding them all and choosing the right one for your needs might seem overwhelming. And the key lies in abstract thinking. Let me explain. Let's take an example of trees. There are different types of trees: mango trees, apple trees, tall trees, short trees. However, at their core, they all share common characteristics like roots, branches, and leaves. So in abstract thinking, if it shares 3 common characteristics, it's a tree. Now let's use the same approach for data structure. Consider arrays. There are one-dimensional, two-dimensional, or multi-dimensional arrays. And when you think in abstract way, you don't need to dive into complexity of each type. So in abstract thinking, you can simply imagine arrays is collection that can hold values and vary in size. So this abstract thinking or viewing things in terms of abstract data types is a powerful way to grasp the vast world of data structures without getting overwhelmed by details. Now let's talk about effective learning strategies for data structures. It's not about memorizing a bunch of concepts, it's about understanding them. But how? Let me share 2 key points that helps you to understand data structure in a more graceful way. The first is visualization. Visualization is the key. It's one thing to read about an array, linked list, or binary trees, but it's a whole new experience to see them in action. When you visualize, you are not just seeing a structure, you're understanding the relationship, the flow, and the way data moves and changes. And I found a great tool online from University of San Francisco. It provides visualization of common data structure. And the second key point is practice. Theory is great, but programming is hands-on skill. To really learn data structures, you need to code with it, break it, and fix it. Now let's try to solve a real-world problem. Write an algorithm to reverse a string. It is one of the common questions asked in many interviews. It might look straightforward, but it's a great example to apply our learning strategies. Step 1. Let's try to visualize the problem. Imagine a string as an array of characters. Each character occupies a slot in this array. In computer science, we often start counting from 0. So if your string is hello, H is at position 0, E is at position 1, and so on. Now reverse a string means that the last character becomes the first and the first becomes the last. Think of it like flipping the entire line of characters. In our hello example, O will move to position 0 and H will go to position 4. So technically we can use a couple of data structure to solve this problem. The first is stack and second is array. Let's see both. And here I will use C# programming language to implement this data structure. But you can use any programming language as the logic will remain same, but the syntax might change. So in this example, I'm including system.collection.generic namespace to gain access to the stack class, which allow us to create and use a stack data structure in our program. And here in this code block, I'm pushing each character of the input string into a stack. And then in this logic, to pop character from the stack and append them to a new string. And finally, it returns a reverse string. And now, let me share the same program, but with a different data structure. And this time, I'm going to use arrays. And here I'm reversing a string using an array. And the main steps are, first I'm converting the string to a character array. Then I'm using 2 pointers, left and right, to swap characters from both ends of the array. And I will continue swapping until the pointers meet in the middle. Now, this brings us to an interesting question. When writing an algorithm, which data structure we should use? And how you measure the efficiency of a program? And how you measure efficiency of an algorithm? How do you decide which one is good and which one is bad? I've answered all this question in my upcoming video, Algorithm and Big O Rotation. I will explain how to select the right data structure for your needs and evaluate the efficiency of your algorithm. Make sure you check out the link in the description, and thanks for watching.